Can you hear me? Oh, okay. The project is targeting a TRL 2 and 4, between 2 and 4, and it's developing the 6G NTN component, but also having an interest in the standardization phase in 3GPP, especially release 20. So there are some use cases targeting the consumer, and there are use cases targeting more verticals, especially onboard vehicles, land vehicles, train, aeronautic, drones, and so on. If we can summarize, the main added value of the NTN component will lie in the ubiquitous and resilient connectivity, which is one of the objectives of 6G. The ambition of this NTN component is not only to improve the user experience and providing more in terms of performance, service performance at broadband, but also increased reliability in the service, reduce the latency through different means, and to provide coverage in light indoor or in-car areas with a smartphone directly connected via satellite. We are also considering to increase the accuracy of location, but more importantly, to reduce the latency to obtain a UE position and to increase the reliability. We're working on ways to adapt the terminal design to the constraints of vehicles and drones. The related industry are very specific about this installation constraints of terminal. So basically, we need to reduce the size of the terminal so that they can be more adapted to this environment. I would say that as part of 6G, there is going to be some improvement for smartphone connectivity and consumer, but more will be done to address the vertical requirement. In terms of network capabilities, thanks to a native integration within the 6G system, we hope that we can contribute to the overall resiliency of the network, as the economy of a country is heavily based on the digital economy, and digital economy is heavily based on the availability of telecommunication networks. So if 6G can fulfill these requirements, that's going to be very important. We may have to address spectrum sharing in certain spectrum or between orbit, so between two NTN components. The environment footprint is also of interest, and therefore we believe that combining NTN terrestrial network can smartly go in the good direction with respect to these KPIs. Obviously, with the deployment of, I would say, distributed network architecture that are in the sky, the security is going to be a big issue to address. Capacity is always something which is needed. Less dependency to GNSS is a desire, and that goes together with the resiliency. And NTN can enable some fast network deployment in areas where everything has been impacted by disasters. And we're working on the multi-connectivity and mobility across the different NTN access, as well as between NTN and NTN. And that includes the interoperability with the 5G access technologies, whether TN or NTN, and will help to support the resiliency. If we look into the possible performance requirements that are associated to NTN in 6G, you have here a table which, is too small to go through, but it gives you an idea of what performance step we will try to achieve when we're investigating as part of the project. Obviously, it depends on the terminal size. But if we are considering terminals adapted to vehicles or drone with limited aperture, for instance, we are targeting quite interesting broadband performance. For the location service, as I said, we're focusing on the reduction of the latency to obtain the positioning, but also to increase the reliability of the information which is measured. Coverage is going to be a big challenge to achieve light indoor, because that requires to be able to free a link margin sufficient to mitigate the building penetration loss. Reliability is something that we can achieve by various means, and latency and connection are going to be improved. The overall architecture that we consider is a 3D network concept with network nodes embarked on each of the NTN vehicles, whether they are at geostationary orbit or non-geostationary orbit. The more interconnection possibility you have, the more you contribute to the overall resiliency of the 6G system. But the NTN component will never achieve the same level of service performance as terrestrial networks. The edge can just help to improve the resiliency and the coverage, but cannot in any way, I would say, replace the terrestrial network, obviously. In this picture, we also highlight that the network will have to accommodate different terminal types, whether smartphones, vehicle-mounted, drone-mounted device, or any kind of moving platforms on board. Even we can envisage some terminals on board HAPS or even on board satellite. The radio interface, we hope that we can achieve quite a lot of synergies with the terrestrial radio interface. However, we recommend that from start, in the context of 6G, the waveform be relaxed in terms of synchronization requirements, or accommodate some asynchronous access to achieve GNSS-free or independent operation. We also promote the need to do enhancements at modulation and coding to operate under very low SNR conditions that would allow to overcome the building penetration loss, not only for NTN, but also for terrestrial network in deep indoor environment. That may be useful. We would like also to have the uplink downlink framing structure be a little bit flexible to reduce the overhead penalty associated, for instance, to the cyclic prefix, given that in satellite propagation channel there is quasi no multipass to accommodate. There are some specific reference signals that could be added to provide some positioning services using the 6G radio interface. The same with joint communication and sensing. However, for this, obviously the resolution of these sensing capabilities will never be the same as terrestrial network, but you can do interesting applications with this kind of feature. Broadcast multicast is something, of course, of interest. Artificial intelligence, I will not go too much because you have already mentioned. Spectrum sharing is something to be considered in certain frequency band as appropriate, and new spectrum are going to be maybe granted at the WRC 2026-7, and therefore 6G NTN could be operated in those spectrum, as well as in the existing satellite allocated services. TTD is another area because there are some unpaired spectrum that have been allocated to NTN or could be allocated to NTN and therefore may be considered. If we summarize in this table, we distinguish between the narrow and wide band connectivity to smartphones or vehicle drone mounted with omnidirectional antennas. That's basically FR1 or FR1 NTN. There are some additional satellite service allocations that may be considered up to in the bands up to 7.125 gigahertz. As per broadband connectivity, definitely KU band and QV bands are something that could be of interest for 6G NTN, together with the same spectrum targeted by 5G NTN. When we look at the overall standardization approach, this is a timeline in 3GPP. The service requirements are going to be developed following a set of study items that are going to be discussed already at the next meeting in May after a workshop. And probably this will lead to a set of service requirements. And then there is going to be stage 2 study items as part of the release 20. And then in the release 21, that's going to be the development of the standard. Here, in parallel, we have the standardization timeline for at ITUR level, and this is ongoing. And here in green is a possible timeline for the satellite radio interface that could be very similar to the terrestrial radio interface. At least that's the ambition. But this will require to develop first a framework document similar to the terrestrial one, and then to define the related requirements, evaluation criteria, method, and submission template in a much faster way compared to terrestrial. However, this could be feasible if we are leveraging the work in Work Party 5D. So in the end, we could have a pretty good alignment of planet to allow the release of IMT 2030 terrestrial and satellite requirements just before the start of the 6G standard. Yeah, that's an annex. I wanted to give you a little bit of background about overall NTN deployment and with respect to the 3 reference scenarios that have been defined in 3GPP for NTNs. It depends on the type of terminals that are being targeted, and based on different documents injected in 3GPP and by different satellite operators or made public, here are the timeline indication of deployment of space segment along the different type of NTN component. I just want to make advertisement of some reference on NTN if you're interested. And last, promote a workshop that is going to be organized in ETSI on 3rd and 4th of April at ETSI premises, especially on 6G NTN standardization. I thank you for your attention, and this is the consortium of the project, and I thank all my colleagues for having helped to prepare this. Hope I'm not exceeding the time. Thank you very much for your attention.